So the question is, can we get this ESP32 that's battery powered connected up to this analog joystick so that we can effectively have a wireless remote control or wireless joystick? Alright, so the first thing to do is I'm going to hook up to ground and then the y-axis, and when it's just sitting in the middle you're at 3.2 kilo ohms. And when you go all the way down on the y-axis, you get to about 200 ohms. And then when you go all the way up, you go to 4.25. Okay, so I rigged up a little input to this to measure the voltage. And so right when it's in the middle, we're at 1.6. When I go all the way to the right, we get to 3.2, which is exactly what we would expect. Full voltage on the analog to digital converter on the ESP32. That's right in the middle, and then when we go to the end, we should be at 0. Let's bring this together. We've got the joystick hooked up here to port 34 and 32. And we're going to go ahead and program this thing. Okay, so let's connect to our device, and let's hit reset to resync it. And then what you want to do is go to the sample code right here, and there's some sample code at the bottom that says joystick. Pull that into your editor, and you get a joystick test and a joystick.lua. So let's go ahead and upload the joystick.lua file, which is really the joystick library. And while that's uploading, you can see here that it's going to require in that library, and then you've got some events like the XY change when it goes to X center, Y center, and then the button. And so once this other file's uploaded, we'll upload this and we will give it a run, and we should be able to see our coordinates spitting out from the movement of this joystick back and forth. Okay, so we got that uploaded. Let's now go ahead and upload this and run it. So let's get ready. Okay, so we'll hit the button. Notice you get a little interrupt on the button. And then let's move the joystick to the left. So we've got an XY change. It goes to 0. When I go the other way, it goes to 4095. And then notice I get that God X center when it's done. And that'll be important because I want to control my CNC machine with this, and I'm going to have to send a feed hold the moment I get that Y center or X center. Okay, so now let's try to, I'm maxing out the Y both directions, but let's try on the X. Let's not go all the way to 0. Let's just do a little bit and see what numbers we get. So you can kind of see you get like a, I'm just barely touching it, and then we'll go to 0. So just barely touching it, I get, 1500 or so. The really nice thing too is this is the first time I've worked with a microcontroller that has a built-in 12-bit analog to digital converter. So that's running at that. I do have a range I had to sort of play with in terms of the X-min and X-max for what's considered the center, and Y-min and Y-max, because when you just start running the analog to digital converter, so for instance if I turn off this and then I will reset and I'll re-upload, you'll see that you get a lot of messiness on the analog to digital converter when it's even just sitting in the middle. You get some noise, and so you're really just debouncing the noise inside your code, and as you saw, works pretty darn well to just debounce. So once that's uploaded, we'll hit refresh on this file list, and we should be able to run the joystick test. So you can see that that's the messiness on the analog to digital converter when it's just sitting in the middle. If I go to 0, fine, and I go on Y. So you just got to debounce inside your code. Okay, so let's put all these pieces together. I'm back in the ESP32 workspace, all fresh and new, and there's now some sample code I uploaded for you down at the bottom. It is the ChiliPeppr CNC TinyG wireless joystick. Hit editor, and you get a whole bunch of files that pop open for you. And I added this new upload all button for you. So let's see if we're connected. And then I'm gonna hit refresh here just to see the file list. And then I'm gonna go ahead and I'm gonna close that unnamed file because I don't need it. I'm gonna hit upload all. And that's gonna start uploading every single one of these tabs, and it'll give us a nice little ding audio when we're done. And so while that's uploading, the main entry point is this main ChiliPeppr joystick.lua file. And it depends on two sub-projects, two sub-libraries, ChiliPeppr TinyG v2. That's right here. This project relies on the Cayenne library. And so I'm going to go ahead and open up this Cayenne window, because when this program runs, we will get it announcing itself on the network. That's what Cayenne does. And the icon should show up here that represents this little device. And so then the other thing is it relies on this ESP32 Wi-Fi. If we go into there, what I realize is that I got to update the password. So I'm going to go ahead and change this to my local password. And then I need to change this other network to my local password. Okay, and so then if we go back to, I'm gonna have to re-upload that file, by the way. And then it relies on ESP32 WebSocket. This is a WebSocket library that I wrote from scratch to talk to the WebSocket on the Serial Port JSON Server. That has its own separate set of files right here, if you wanna just look at that independently. But it does like the ping pong, back and forth to keep the connection going. And then you also have, let's see, once we get to the WebSocket, what else does the WebSocket rely on? It relies on nothing else. And so then you're also relying on this Cayenne Simplified. So that relies on the JSON library, which is separately available in the examples as well. It's a pure Lua version of a JSON encode decode. So that's pretty handy. It also relies on this joystick.lua, which just reads the joystick. That too is available separately if you want to just look at how to control analog joystick. And then that's about it. So this is the main entry point again, and at the bottom is when we do the ChiliPeppr utility.init. And then that will go ahead and connect to Wi-Fi, and then connect to the WebSocket, and then be ready to start sending Gcode commands from your joystick. Okay, we're finished. So now that it's uploaded, I'll refresh the file list. And what I want to do is actually run main ChiliPeppr joystick.lc. We'll go ahead and run that. And you'll see that the Wi-Fi is getting started. Oh, I need to re-upload that ESP32 Wi-Fi file. So let's reset. And Alt-U is upload. Okay, now that that's uploaded, let's go ahead and rerun main ChiliPeppr joystick. And it should now attempt to connect. Perfect, connected to Wi-Fi. And let's hit refresh, and we get ourselves a little icon showing our joystick. And it doesn't really have that many commands exposed, but you can see there's 62K remaining out of like the 167K. So it does chew up a lot. You can also see it's telling you at some point here, it tells you that you should actually connect your joystick by default, but we're also doing the pings and pongs on the WebSocket to stay alive. Okay, so we turn the switch on, and the light starts blinking because it's connecting to Wi-Fi, and then it's connecting to Serial Port JSON Server and finding an actively connected TinyG. And then we can start to go right, go left, go back. That's actually positive in the Y. We can come forward, go diagonal, and then let's try and go really slow. So I'm barely pushing, then I'm starting to push more, and then I'm at max speed. And when I let up, it stops moving. Pretty fun. You can see too what it's actually doing when I scroll. Notice as it's moving in the ChiliPeppr window, there are commands being sent. And the screen is moving. Notice too the light goes on when you're jogging. And so that's how it works. It's actually connecting to Serial Port JSON Server and just mimicking Gcode commands for the jog. Hey, so thanks for watching another fun video on ChiliPeppr's ESP32 for Lua Workspace, where an ESP32 was programmed to control ChiliPeppr running a CNC machine in the original ChiliPeppr TinyG CNC workspace. So go make your own ESP32 device using ChiliPeppr.